Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study how to draw a cam profile when the follower is having a uniform velocity motion. The type of the follower is knife edge follower, and it is having a uniform velocity. Yes, uniform velocity. It is during outstroke uniform velocity, and during return stroke also uniform velocity. So we have to draw a cam profile of a knife edge, in case of a knife edge follower, using the following data. The minimum radius of the cam is 5 centimeters, that equal to 50 millimeter. The outstroke angle is 120 degrees with uniform velocity. In before session we have studied with the simple harmonic motion. In this session we are going to study with simple uniform velocity. And outward dwell is 60 degree, and return stroke is 120 degrees with uniform velocity. Dwell for the remaining period of cam rotation. The stroke or lift of the follower is 6 centimeters, that is 60 millimeter. So with these details we have to draw the cam profile. One more assumption, that assumption here did not mention the axis of the follower, the passing through that is either center of the cam or not. So we are assuming that the axis of the follower is passing through the center of the cam. So that is the assumption. If it is not specified, you are assuming it. If it specifies, then you have to follow the condition which is mentioned in the cam profile in this data. So before going to start that, what to do, we have to draw with this data. If any one data is missing, we have to assume it. Then only we can draw the cam profile. If it is missing, we have to assume it. Otherwise, this data, all these parameters are must and should. One has to know it. These are the input parameters. Then only we can draw the output, that is cam profile. Now, this output cam profile, how to draw? First step, we have to take a scale. Scale is that for drawing the displacement diagram. For drawing a displacement diagram, we need axis X and Y. The x-axis 20 degrees equal to 1 centimeter. Then outward stroke is denoted by theta O, that is 120 degree, that is 120 by 20 scale. Then what will happen? That is 6 centimeters. And outward dwell, the outward dwell, that is theta OD, that equal to 60 degree. In terms of scale, that is 20 degree equal to 1 centimeter. It becomes 3 centimeters. Theta return stroke, that is return stroke is 120 degree, that is 6 centimeters. Next, dwell for the remaining period of the cam rotation. What is the remaining period of the cam rotation? The total for one rotation of the cam, it is 360 degree. One rotation of cam gives, it is 360 degree. So we want the total, that is remaining sum of these 360 minus 120 minus 60 minus 120. Again 60 degree will be left, that is theta return stroke dwell. becomes 60 degree, that is 3 centimeters. With this, all the sum of the outward stroke during dwell, return stroke and return stroke dwell combination you have to draw, that is the length of axis x. So that is the length of the axis x, that equal to, we'll get it as 18 centimeters. So we have to draw the diagram with 18 centimeters line, horizontal line. So after drawing the 18 centimeters line, that is the axis x, then we have to draw axis y. The axis y is the length of the lift or length of the stroke. The length of the stroke of the follower is 6 centimeters. That you draw 6 centimeters in order to complete the rectangle. That is 6 centimeters. So after drawing the 6 centimeters, you complete the portion. Okay, complete the portion. This axis x, x-axis axis, the length of the cam rotation. That is cam rotation. We converted into the linear square. That is 18 centimeters total. In that 18 centimeters, divide 6 centimeters goes to outward stroke, that is 120 degree. Next remaining, that is 3 centimeters is outward stroke return, that is 60 degree. Then again 6 centimeters, that is the return stroke, 120 degree. Again is the remaining portion up to here, that is theta return dwell, that is 60 degree. So divide this 120 degree into equal parts, that is 6 parts. Okay, equal parts, that is equal 6 number of parts, even number 4, 6, 8, 12. So even number of parts, after dividing, we have to draw vertical lines. So we have to make it completely return stroke 6 centimeters, 0 to 6, 6 centimeters. Again 3 centimeters, that is 60 degree, that outward stroke dwell. And it is return stroke, theta return stroke, that is theta return stroke, that equal 120 degree, that is again 9 plus 6, 15, and remaining is the 6, this much length. This length is the outward stroke length, that is 120 degree, and it is outward dwell, that is 3 centimeters. Remaining 60, this portion is theta outward stroke, that is 120 degree, 30 degree, theta return stroke 120 degree, and it is theta return dwell, that is that 60 degree. So it is 60 degree. Now after drawing, you draw vertical lines. So we are doing here, drawing a displacement diagram. Displacement diagram of a uniform velocity when the follower is in uniform velocity motion. It is in uniform velocity motion. Now divide this 6 part into 6 equal or even number of parts. I am drawing here, dividing the each point into 6 equal parts. So 0, 1, 2, 3, 4, 5, 6. In the dwell zone, it remains constant. It is 6. Again 5. Again equal number. Outward stroke and return stroke should be in equal number, even number of parts. So outward stroke is divided into 6 equal parts. Similarly, return stroke also to be divided into 6 equal number of parts. Alright. 6, 5, 4, 3, 2, 1, 0. Now draw a vertical lines. Okay, draw a vertical lines. Similarly, return stroke also complete the join vertical lines. So it is a uniform velocity motion. That's why the mark these points here, it is with A or A S T X. Similarly, this is the B point and it is C. Okay. Now the uniform velocity motion. So the motion of the follower is uniform velocity. It becomes a straight line. Join A to B. And it is the dwell zone B to C. And again it is return, that is CX. Okay. Now join this. Now if you join, no, this is the displacement diagram. And it is the displacement diagram as I shown you before. And just mark the points. This is 0, 1, 0.1, 2, 3, 4, 5 and 6. Here becomes 6, 5, 4, 3, 2, 1, 0. So this diagram is known as the displacement diagram. What is the height of the axis Y? It is a lift or stroke. That is stroke equal to 6 centimeters. And what is an axis X? The axis X, the total distance is how much? It is 18 centimeters. In that 6 centimeters goes to outward stroke, again 3 outward during dwell during outward stroke, return stroke, and again dwell during return. So this axis X represents the cam rotation. That angular motion is converted into the angular displacement is converted into the linear scale. That is then we have drawn on axis X. Axis Y denotes the lift of the follower, the stroke of the follower, that is 6 centimeters. So this diagram is displacement diagram. Displacement diagram of a follower during cam rotation or during rotation of a cam. During rotation of a cam. So that is the way one has to draw the displacement diagram when the follower is under uniform velocity. Okay, after this, the vertical line is intersecting an inclined line. You make it as a point A, or you can mark it as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Similarly, it is 6 dash, 5 dash, 4 dash, it is 3 dash, 2 dash, 1 dash and 0. So these are the points. Now what to do? We have to draw a circle having a basic radius. That radius was given here. That basic radius was given. The radius of that one is, what is the radius of the cam? That is the radius is that the 6 centimeters, 5 centimeters is the radius. Now we have to use, as we have drawn that displacement. I am going to draw again completely the picture. This displacement diagram. This is outward stroke, that is 120 degree, and theta outward stroke dwell, that is 60 degree. Theta return stroke, that is 120 degree, and remaining thing return stroke dwell, that is 60 degree. Now, as I have told you, divide this into equal number of parts. 0, 1, 2, 3, 4, 5, and it is 6. Draw vertical lines. Equal number of parts you have to draw, even number of parts. The even number of parts are 6, even number. You can also consider 8 number of parts also. Similarly, here also you have to divide. So it is 6, 5, 4, 3, 2, 1, 0. Okay. After joining, what we have done? We have joined, it is a uniform velocity motion. We have joined completely from O to, as I shown you, it is A and it is B and it is C and it is X. So, direct straight line, the uniform velocity. So, you join A to B. Join A to B and C to X. This is the uniform velocity displacement diagram. Now, as is given the basic circle radius of the cam, basic radius of the cam is 5 centimeters, that is 50 centimeters, 50 millimeters. So, draw a circle having the radius of 50 millimeters is the 5 centimeter. Draw a circle. Here I am using the freehand sketch. You have to use with the help of the compass. Draw a circle of 50 millimeter radius of the circle. So, this is the center. As I told you, the axis of the follower is passing through the center of the cam. This is the point of the follower. This is the point of the follower. Consider that with a free hand. There is no dimensions of the follower here. It is we are following a knife edge follower. And what is the outward stroke? From this, the rotation begins. What is the angle of outward stroke? That is how much? It is 120 degree. 120 degree. This is 120 degree line. It is the outward stroke, theta O, 120 degree. Next, divide this complete circle into outward stroke part or dwell during outward stroke and return stroke, and also return stroke during dwell. Dwell during return stroke. And here it is 120 degree. Next, 120 plus 60, 80. This is remaining 60 degrees or outward stroke, dwell during outward stroke. Then make it one more 120, that is return stroke, is 180 plus 120, that is 300. This stroke is the return stroke, 120 degree. And the remaining angle is the return stroke dwell. Now what to do? We have already divided this outward stroke into 6 parts. The same on this base circle radius of the cam also we have to divide that outward stroke portion, that is 120 degree, into 6 equal number of parts. The 6 equal number of parts are, this is 120 degree by 6. That means it becomes each 20 degrees. So divide this 120 degree into angular division of equal 20 degrees, equal number of parts. This is 0. Here I'll change now. It is 0 point. Next part is 1, and it is 2, and it is 3, it is 4, it is 5, and it is 6. Then after that, what to do? We have to pass through lines, radial lines of the cam through these points. Okay. Similarly, there is no developed during outward stroke. The follower remains constant motion. There is no upward motion. I say rising. There is no neither rising nor falling. Next, return stroke should be divided into again 6 equal number of parts. Again, divide the return stroke. This is 6, 5, 4, 3, 2, 1, 0. Draw a radial lines for the return stroke also, passing through these points. So how to divide the outward stroke? It is equal number of angular divisions. With the help of protractor, you can divide. Similarly, return stroke also you can divide into equal number of parts. Now we have divided 6 equal number. Why we are doing? It can become 8 also, but it should be a equal number of parts what you have divided in displacement diagram. In displacement diagram, the outward stroke is divided into 6 equal divisions. Similarly, during cam profile drawing also, that outward stroke is divided into equal number angular sections, equal number of parts. Similarly, return stroke. And one important thing is that whatever divisions, equal divisions we have done, that means even number of divisions done for outward stroke, outstroke, same thing should be done for return stroke also. And suppose outstroke is divided into 6 and you want to divide return stroke into 4. No. Okay, should be equal number of parts. Now, next step. What is the next step? The next step is we have to measure the displacement. Now, from measure 1 to 1 dash, this is 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, and it is 6 to 6 dash. Similarly, this point is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and 0. Now, with the help of compass, take the distance from 1 to 1 dash from displacement diagram and mark a point. It is the point 1 to 1 dash. Okay. Similarly, take the distance from displacement, that is 2 to 2 dash, and with the help of compass is the center 2 in the cam profile, 2 to 2 dash. Similarly, measure the distance from 3 to 3 dash from displacement, and coming to cam profile circle and the base circle of the cam, center is the 3 on the circumference of the circle and mark 3 dash. Similarly, 4 to 4 dash, 5 to 5 dash, and finally it becomes around 6 dash. Similarly, now return stroke, you measure from 6 to 6 dash, you measure from displacement, mark on the line, that is 6 to 6 dash, approximately 6 dash. Similarly, return stroke 5 to 5 dash length is the 5 and it becomes 5 dash. Similarly, 4 to 4 dash, it is from 3 to 3 dash, 2 to 2 dash, to 1 dash. On one line, it is the 0 line. 0 to cutting that the intersecting point. Now, after doing this, what to do? We have to draw a curve by joining all these marked lines, which we have taken the lengths, distance from displacement diagram. Now, how to draw it? Join the curve. This is a point O, 1 to 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and passing through all these joinings. Again from 6 dash, 3, 1 and finally it is. Now this is the cam profile. The curve traced by the displacement of the intersection points on a base circle diagram or cam profile radial lines. With these radial lines are intersecting 1 to 1 dash, 2 to 2 dash. These distances we have taken from displacement diagram. After joining these intersecting points with a smooth curve, freehand sketch, so that curve profile coming, that is called cam profile. It is a cam profile. Conditions under the given conditions. The given conditions are the type of the follower is a knife edge follower, and the type of a knife edge follower and the velocity, the motion of the follower is the uniform velocity motion during outward stroke and return stroke. So again, if you the shape of the cam, how the cam comes, the shape of the cam is, this is the shape of the cam was obtained after drawing the cam profile. So this is the cam profile was observed or drawn by for the given conditions. The given conditions are the type of the follower is the knife edge follower, and the axis of the cam on the axis of the follower is passing through the center of the cam, and outward stroke is 120 degrees, and dwell during outstroke is 60 degrees, and return stroke is again 120 degree, and dwell during return stroke is 60 degrees. And the length of the lift or stroke or lift of the follower is 6 centimeters, and the basic radius of the cam or minimum radius of the cam is 5 centimeters, that is 50 millimeters. Under those conditions, the cam profile, the shape of the cam profile is, this is the shape or the cam design, the geometry. Okay, this is known as the cam profile. So this is what we have learned. But one thing is that during outstroke and return strokes, the follower is having only one motion. That motion is uniform velocity motion. Uniform velocity motion during both outward stroke and return strokes. Okay, next, if you want to discuss another combination, the same problem, but during outstroke can be a follower can be having simple harmonic motion, and return stroke during outstroke the motion of the follower is simple harmonic, and the return stroke the motion of the follower, it can be a uniform velocity. Then what is the shape of the cam profile? Is it will be same? No, it will be different, because the outward motion is during outstroke the motion of the follower is simple harmonic, and during the return stroke the motion of the follower is uniform velocity. Under these conditions, what is the shape of the cam profile will be studied in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.